Today we're going to talk about recursion, one of those topics that maybe people hear the word, they're not quite sure what it means, sounds a bit scary. It's often in the later sections of JavaScript textbooks, so you think, oh, it might be a bit advanced. But in a nutshell, it's just a different way of solving some algorithms or solving some problems, and essentially it is a function that calls itself. So within a function body, the function will call itself. So we're used to doing things like that, where we've got one function and perhaps we call another function from within our first function, yeah? So you can see we've got a function A and a function B. So function B should just return a string. Function A itself returns the result of function B. Yeah, you've done this time and time again, either in your React components or even when you're on the JavaScript training. Even in beginner, right, we saw some functions that called other functions within them. So it's one of the powers of JavaScript, right? We can do lots of powerful things with our functions. So when I do call function A down there, it will return that line and therefore return whatever was inside of B. So the only fundamental difference between that pattern and a recursion pattern is, rather than returning a whole different function inside of itself, at some point function A will call itself again. Now there's obviously a problem with that, with writing it that way, because we will just be stuck in what if I do that. If I define a function, then I call it and that returns itself, what's going to happen? Yeah, we're just going to be stuck in an infinite loop, right, if I do that. But fundamentally that is the design pattern of recursion, right? A function that calls itself. But of course, if you want to use recursion to solve your problem as opposed to an iterative method, so looping over, using for loops or using some of our other modern functions that we have, or modern methods that we have available in JavaScript, then we need to make sure that we have some sort of condition, right? So that we're not stuck in an infinite loop. So the function would only call itself based on some criteria. So that might be as simple as an if-else statement, and only if a certain condition would we recursively call the function. Otherwise, we'll do something else that will either break the function, as in break I mean return something else and not recursively call itself, or yeah, just end the current function. So yeah, in a nutshell, that's what it is, a function that calls itself, right? That's all recursion is. That's all you need to think of it as. And for certain problems, recursion is a lot neater way to write and to solve problems than using a looping iterative approach. So we're going to have a look at some of those examples today, mainly based on our JavaScript expert training. And we can see how we can solve these problems with recursion that will probably be quite a bit harder to solve just using loops or iterative methods. Any questions on what recursion is before we move on? Or someone tell me what it is. Function that calls itself, yeah. And that's all I want you to get out of this part, yeah. Nice. So, has anyone done the recursion training yet on the platform? So Richard's had a go. Vince, you done some yet? Anyone else had a look yet? Nope. Cool. So this should be very relevant, hopefully, for you. All right. So this is the first question we have on recursion, and you'll probably notice a pattern when you start to see recursion problems. And that pattern might be that we have some sort of nested data. So we can't always count on our values in this case to be a number. It might be a number, it might be an object, it might be an array. There's various branching in our algorithm, right? Recursion lends itself very well to algorithms or problems that branch. So in other words, if our data type's a number, do one thing, If it's an object, in this case, do another thing, right? We've split off our algorithm. On our flowchart, we've gone in different directions. We handled the problem in different ways. Cool. So what are we looking for in this? Well, we are looking to add, all of the numbers. And that doesn't just include the numbers that are direct values of these properties, it also includes the numbers that are nested within this other object. Yeah? So, any ideas how I would start that? Or does anyone want to have a go using a loop to begin with? Maybe just some for or some if loops? Yeah. So we're going to use reduce and we're going to use recursion to easily solve it, but I just wanted to know whether anyone wanted to try a different method first and we can perhaps see how it's not as advantageous. Anyone got some ideas for some pseudocode, if nothing else?
It can be first object of values, then you can find the value, is it a number?
Yeah, I think that's a really nice way to start, right? Let's just get the values out of this object, out of this argument, yeah? So I'll just call it obj up there, just for object, yeah? How do I get the values out of an object? Object.values, yeah. Capital O for the object, so object.values, and then I'll pass my object inside of it. I'll just store that in a variable for now, right? We probably want to use it later. Okay, so now I've got an array in this first case of 1, and then another object that contains C and D, and then number 3. And eventually we want to just reduce it into the total, right? We've done this many times before using reduce, so let's try and do a similar sort of format, but we've just got to handle this extra case here where it's a nested object, which makes it a little bit trickier, but not too much. So if we did values.reduce, right, usually we'd set it up to maybe calculate the total. We've got our current val in there. I'll leave it at that for now. And we're going to use an arrow function. You in? Yeah, so it's just a function, but just using this arrow instead to show that it's a function. And then usually we end up just doing something like return total plus current value, yeah? Return total plus equal, yeah? Usually we end up doing something like that, right? But we're going to run into a problem in this case because we're not going to be able to add the object on, yeah?
Which is the plus equal to again?
So it says total equals total plus current value. Yeah, it's just shorthand for total equals total plus current value. It gets us a running total. So let's see. Let's see what error this throws first. So we've actually concatenated it into a string, right? That's what JavaScript has done behind the scenes. It's taken the value 1, it's added on this object, I think, as a string, and then added on number 3. So it's not been able to add on the values inside of here. So I think Nolofa was suggesting we can detect whether it's of type object or type number or something like that. Yeah. So inside of our reduce we can do that, yeah? So what would be your method perhaps? So do you want me to use an if statement for now? Or ternary? What do you want me to use? Ternary? Yeah. So if I give it a variable and say to add, so in other words, that's the number that I want to add onto my total. Rather than using current value, which could be an object, I'm going to add on my to add variable instead. So this we need to make sure it's a number. So your option was, you said if.
Yeah, just to add the number.
So you want to do something like that? If current value equals or what? So we need a type of as well, yeah? Type of current value equals number. Then oops.
Number there as a string.
Number is there as a string because when we use the type of operator, which Porit's going to talk about this afternoon, then the value returned from that is a string that lets us know what object or what data type the value is. So if it's a number, what do we want to do? Just add it, right? So in other words, if it's a number, let's just say, yeah, keep the current value, right? Not keep the number. So keep the current value. Current val, yeah? If it's not of type number, what could we do instead? Somehow we've got to get the numbers out of this object.
So I will view object of values and do the whole same process we've done already.
Yeah, either you can essentially repeat all of this code, or
You've got calculate total on that object there.
yeah, or we call our same function again, but this time the object that we pass into it isn't the original object. We're going to pass in this object here, yeah, which is actually our current value on the second iteration of our reduce function.
Is that the recursive part?
That's the recursive part. Yeah, we're calling the function again. The function is calling itself. So calculate total. And what do we pass in to calculate total? Well, we pass in the current value. Something like that. And the way it works in JavaScript is this whole function is going to run to completion before this line runs again on the second iteration, yeah? In fact, what we're probably going to do, I think we'll take this out into DevTools and we'll put some breakpoints and cross our fingers and hope that the breakpoints work today and we can clearly see what's going on.
I would initialize total to 0.
And yeah, in this case, it makes a lot of sense to initialize our total to 0. Why would we do that?
So otherwise total would be the first element in our array, and if it's an object it wouldn't be checked.
Exactly. So in this first case, it's okay because it was a number 1 to begin with, but what if we had an object as our first value? Well, we're going to be trying to add things to an object and it's just not going to play nice. Cool. Where am I missing the semicolon? 5-4? Really? It's because I put the parentheses there. It's only because I wanted to drop down a line. I don't know whether it would do it without that.
Previous time you submit.
Oh, was it? Okay, that's fine.
9.
Yeah, I saw that one. Yeah. So have I not run this again? Have I? Yeah. I mean, so that works, but we will put some breakpoints in to see what's going on. See if we can explain what's going on at each stage. See if you can tell me the current value of current value. See if you can tell me the current value of to add and things like that.
I don't think we need to put total plus equals to add, although plus equals does work because of a weird thing with Java.
Yeah.
That the sign also returns the value.
So we could just do that, right? As I originally put. Yeah. Okay, so let's go over into DevTools. What have I got here? That's for a different question.
Why did you remove it?
Because at each iteration, all we're doing is taking the total and adding on a value to it, and that becomes the accumulator, doesn't it, in the reduce function? So therefore, we've essentially stored it in the accumulator, which is total anyway, yeah? So we don't need it. Let's clear that. Right, so where am I going to put this? Let's see. Best place to put a breakpoint. I was waiting for the dog to bark then, but he's not here today. That's why Abdul's here. Hey? Yeah, yeah, absolutely, always. Could try one there. Yeah, line 2 might be alright as well. Okay. So, we need some data to make it work. Which one do you want to do? The first one or the buzz, blah, fizz? Well, that one's even more complicated. Let's try that one, right?
The last one I just.
Yeah. So the last one. Have I just copied the wrong bit, right? I need the whole thing. Alright, so my question to you is, firstly, what is the total and the current value going to be on our first iteration of reduce? So at the very start, ideally line 5 should do it. When it stops on line 5, what is the value going to be of current value and total when it stops for the first time on line 5?
Total will be 0.
Total's the easy one, yeah, that'd be 0, definitely.
And current value would be 9214 equals 1.
Yeah, and current value is going to be this object, yeah? That's what we are thinking. So therefore, what part of my code is going to run? Is it going to just return the current value, or is it going to call itself again? Yeah, it will call itself again, yeah? So let's see if we can visualize that. So that's obviously just stopping at the top. We can see that we're getting our object.values. We can see what the object is. No worries. Moving on. Just going to stop at each point. Lovely. Yeah, so then it didn't stop on line 5, but that's fine. It jumped down to trying to call the function itself again. We can clearly see that the total is 0, and the current value this time is exactly what we said, the first object, yeah? So next, that reduce function is essentially going to pause at that point while we call the function again. This will create a separate execution context, a separate function if you like, which will run through to completion. And then when it has returned a value, then the rest of this first function will complete. Yeah? Or at least go to the next iteration of this first function. Let's see, hopefully if we can see that. So when we call it again, we expect the total to be what? Still 0. Yep, it's a different 0, but it's still 0. And we expect the current value next time round to be... Yeah, the current value we expect to be 2, but the vals variable, if you like, yeah, we expect to be 2, 4, and 1, if that was your comment, Nalofa, yeah? Let's see if we can see that. So it stopped there. Our object this time is the value from the previous function. Where's it going to stop this time? Yeah, so it's jumped quite a bit ahead, hasn't it? It didn't stop, unfortunately, on line 5. Can you see now we've got a total of 10? So it's already managed to do the 2, the 4, iteration. Our values equal to 2, 4, and 1. Line 8 items in that list. So what does it do? Well, it finishes the second dimension of our reduce function, if you like, and pops back out to that first reduce function that we had. The next current value in that first reduce function was our 3. So again, it checks, is that number 3 equal to a number? Yes, it is. So therefore, add it on to the total. And the total would already become 7 from running through that previous reduce function. So we end up with 10. And now it's only paused on the case again where our current value is an object. So rather than just being able to add it on, it has to recursively call itself again, yeah? To add on these 2 final numbers. So what should our final total be in the end when everything is finished running?
Where does current value get added to the,
Where or when?
to the total? Yeah, when?
So we say to add equals that, so either current value or calculate total current value, and at the end of it return total plus to add. So to add would be the current value or call function current value.
Yeah, so when it gathered all of these 2, 4, and 1 together and totaled them to 7 in the previous reduce function, that has become our to add value of the first reduce function. It's really hard to explain in words, this. Maybe that's why people get put off, right? But yeah, the best way is to just add some breakpoints for your own code and see if you can get it to pause and predict what the values you expect it to be. Abdul, you had a question?
You know when you call the function on line 7?
Yep.
Does it start running the program again from or execute from line 2 or from line 3? And does it execute it to line 6 or does it execute to line 8? How is the cycle?
Yep. So when it calls itself, you want to say, Richard, or?
So calculate total, we have one calculate total function running, and then when we get to line 7, it sees another calculate total, so it pauses, the first one pauses there, and it spawns another function, which is a completely new instance of calculate total, which is going to do the same thing.
From
Yeah,
2.
from 2.
Yeah, the whole thing.
Start on the start again.
Okay, from 2 to 8.
Yep, or 2 to 9 if you like, yeah.
Okay.
Once that's done,
Okay,
it turns
in a
out
different
to-
branch. Okay, and then wait one side.
Yeah, and once that spawn of calculate total has finished, it passes its return value onto the first instance of calculate total, yeah, so that we can add them all together.
Is this like an
So
MQ?
where does it pass it to when that is finished?
Which, so,
So once
yeah.
the spawn one is complete,
Yeah.
so on line 7, we created a new function where we run the same thing. When that same thing is completed, it returns that value all the way back to line 7. So that value on line 7 is what we get. So we say let add equals that value that we just got, and then we continue to line 8, so return total plus 2 add.
Yeah, so you've essentially got calculate total original. So calculate total original will pause because this is an object, and then spawn calculate total, should we say instance, so that's instance 0. So once instance 1 has been spawned, it should be able to just reduce this into a total, right? Because it's just one single object. So that is going to return eventually 7. And that passes 7 to your original calculate total instance. That's not any clearer at all, is it really? But hey. How else can we show it? I might need to use the board, right? We can draw stuff on the board if you want. We'll do that afterwards with a problem.
If you did that, maybe indentations to show nested.
Yeah. Could do. So you've done like what? 0 plus 2, and then you've done 2 plus 4. The next iteration. Final iteration of our first spawn does what? 6 plus 1, exactly. And then it returns 7 right at the end. And because it's returned 7, it's finished, right? We can garbage collect that spawn, that instance is done. Nothing else to do there.
Does it one set time for each element of the object?
Yeah, that's what reduce does. Reduce iterates over each element in the array, yeah? And what we're telling it to do is to take the current running total, the current accumulator, and add on either a number or call itself again. So that's why it's adding on this to add number at each stage. And then when it's finished, it will pass 7 to our original. And that means the original total does 0 plus 7. Yeah, because it's taken all of that as 1 as its first iteration, and the to add value was 7. Next, what?
So we'll go back to the code also.
Go up where?
For the outputs, yeah. So that's 7, where you split it to.
That 7
Yeah, where is it?
has been assigned to the variable to add
To add. So it,
on the first iteration of the original calculate total. But to get that, we had to run all these instances of our recursive function. All these iterations, sorry, of our recursive function. Yeah, so we got 0 plus 7. So next time around, we're going to do 7, becomes our new total, plus Well, we've just got a number here, so we can do that directly. We don't have to spawn any new recursive function. So we get 7 plus 3. Next time around we've got 10 plus, well, we've got an object again. So what's going to happen? It's going to be the result of calculate total spawn 2, yeah, with that object passed in. So next we're on our spawn 2, let's put it over there. And what have we got? Well, we've got the number 3 as our value. So do I do 10 plus 3 here or something else? It's not 10 plus 3 because we've done a whole new instance of our calculate total. So that means we've also reinitialized our accumulator to 0 for that function, yeah? This one's still there held in memory, 10 plus something, but we're going to get that later on. So we, inside of our next spawn, we're doing 0 plus 3, right? And then coming down, next time around, our total is going to be 3 plus 1, right? Are there any more iterations to go in that reduce function? Absolutely not, right? So it's going to return 4. And it returns it back to our original instance. What did we have previously? Well, our running total was 10. Now we can add on the 4 that we've got from recursively calling our other function to finally end up with 14 there. And that was at the end of this line. So there's nothing else to run inside of that original reduce function, and we end up with 14. So there's a lot of steps, but you know, you've only written this algorithm once, and it's able to run itself again and again as needed, which is where the power of recursion comes in, yeah? With the indentation, that was Porik's idea, again, thinking outside the box, thanks Porik. Cool. Yeah, so we've already taken quite a bit of time, but should we look at another example just to put that into practice? Yeah? Okay. Of course, we could do the proper indentation, but I'll skip that for now. So this one's very similar, right? Get the maximum value as opposed to getting the total. So how am I going to set it up? Probably the same as before. Can someone run me through it? It's an object in there, yeah. And we want to get the object's values. Yeah, I'll do it in a variable for now. Let vals equal objects of values, passing in our object. Next, what do we probably need to use? It goes very well with recursion in general. Reduce, yeah, reduce on the values. Arguments, probably going to be some sort of accumulator, and I'm just calling it CV for now because I'm really lazy. We of course need some brackets around it because we've got more than one argument. An arrow function, probably some sort of initializer. I'll put it at 0 for now, we'll argue that case later. Yeah. So that's sort of the setup, right? And now, what do I need to do inside? I'm going to call my accumulator max. Are people okay with that? Because we're trying to return the maximum at the end, yeah?
So if the current value is a number,
Okay. I'll write it like this for now, yeah.
So if current value is a number, return current value, it's the same as before. If not,
So you want to use a type of again, yeah?
yes please.
Yeah.
You can use the not number thing if you want.
Not a number, or
I mean like
just number?
it's type of value, it's fine.
Yeah?
It's still value, yeah.
Okay.
If it's a number, then return current value.
So if it's a number, return current value. Maybe.
If not, then run the function again to get max value.
Okay, let's see what happens if we do it this way then. So you were else. Oh no condition, right? And you want to return again, or
Rerun the function. So
just get max value?
yeah,
Yeah.
that one.
Passing in anything?
The value. Yeah.
Current value.
Yeah.
Well, it will pass the first one.
Yeah. So declare to a variable the whole thing.
The whole thing. So you want what, like a candidate max?
Yeah. Let's use the
Okay, let's rewrite it as a ternary.
yeah, please, yeah.
Oops.
So next line.
Yeah.
Yeah. So after line 7.
Yep.
Type in return. Candidate max is higher than the max. Then return candidate max. If not, just return max. Alright.
So if candidate max is greater
Yeah, higher than max.
than max,
Then return candidate max. If not, just return max. So that should be a question mark, shouldn't it?
Yeah.
sorry, yes.
Yeah. Correct me if I'm wrong.
Hmm?
Correct me if I'm wrong.
Correct you if you're wrong. That kind of makes you return.
But the zero, you can't really use zero again because of the minus, because of the negative number.
Yeah, there's a minus 3 there that's gonna.
Yeah, so it might not work because of the zero. So you might need to use.
Let's put that minus 4.
Yeah.
It will work in this. It will work in this case, but yeah, it will just the maximum will stay as 0 at that point, and then it will get set to a 2. Then it will get set to an 8, and then it will still be an 8. So it will still work in this case because our highest value, our maximum value, is greater than 0. But you raised a valid point. If our maximum is a negative number, then we're still going to return 0 because that will just stay as our maximum throughout, right? So yeah, we could be really cheeky and look at our test cases and put -4, but that's not really a very good solution. So what could we do? Well, we could use negative infinity, right?
Oh, yeah.
Infinity as a number, and that will make sure that any number that we put in will overwrite our negative infinity.
It's a number, isn't it? What's it called?
Another?
Mean integer or something.
Oh, can you do that? Maximum, minimum integer or something? Minimum, yeah.
Yeah, that one, yeah. You know what I mean, yeah.
I know what you mean, but I don't know the exact phrasing.
Dot min math dot max.
Oh, I know.
No.
Mean save integer.
It's a constant, right?
Oh, it doesn't matter.
Yeah.
I think that's fine.
If you can Google it, I'll put it in and test it. But oh,
Value.
hold on, we didn't return anything because I didn't put a return up there, so that's my fault. And then we're all good. All right.
Got it.
It's a number,
Yeah.
capital number dot min value. And min
Yeah.
value is all in caps with
Yeah,
a
that's it.
an underscore between min value.
Min underscore value, like that.
Yeah, and you don't need the minus. I think.
Oh no, I didn't mean to have that.
That's fine.
But Joey, you know when I see this question, the first thing I think about is the maths method.
The max method.
Max maximum.
Yeah.
Max,
So instead, you might have wanted to push everything into an array and then do math.max on that ending array. That's also possible.
And you need to use math.
Would we do map? How would you? You're gonna probably end up with a nested array if you use map, right? How are you going to turn that object just into two separate entries if you use map?
If we use math on the, sorry, max on the, well, I mean, if we have a formula for it within the object, and we then have to work on B, can't we recurse it at that stage for the B object? I'm just thinking, like, will it not work that way, or I don't know how to implement it, but once I see maximum value, that's what I'm thinking of, like initially.
Yes, I mean, firstly, you've got to end up with an array, right, with 2, 1, and 4 in it, and then you can call math.max on it as usual. The question is, how are you going to get your array to have 2, 1, and 4 in it, as opposed to 2, comma, object with C1 and D4 in? Yeah, that's the problem you've got to solve.
Okay.
Could you do that recursively? Yeah. But I still think this way is neater, and reduce makes sense because you're just reducing it to one value. It's a two-step process, yours, right? Create an array and then call math.max on it, whereas this is just all done inside of one reduce.
Small tidbit about the min value thing. So number.min value is actually the smallest possible positive number you can represent.
Ooh.
So that would be like some float 0.0.
Okay, so again, if we had negative numbers, that would break it.
So the biggest number we can represent in JavaScript would be number.max value.
Yeah.
And we do minus number.max value.
Minus number.max
Anything
value.
bigger than that is infinite. So we could say minus infinite is the correct way to do it.
Mm-hmm. So technically you could do that, right? Minus number.max value, but the better way is as we originally had. As minus infinity, yeah? Okay. Yeah, I think so. Does anyone want to go through the steps here and explain what's going on, or are you happy just to work through that in your own time?
Step 8, what does step 8 do?
Step 8.
Yeah.
So, as a result of either the current value being a number or recursively calling getMaxValue, candidate max has ended up as some number. It's either going to be the current number in the list or the maximum of the object, if the current value was an object. Then we're saying take that number, which could be the new maximum, it's a candidate for the new maximum, compare it to the existing maximum, which initially was minus infinity, but if we'd already run one step, it would have been 2. So compare those two values. If candidate max is greater than the max, then our accumulator just becomes our candidate max. Yeah, so if 4 was greater than 2, then of course our new accumulator becomes 4. And if our candidate max was actually less than 2, then we just retain our original maximum, which was 2. Yes, that's just a ternary. 8 works together with those two other lines, yeah? Sort of. If not, run it in DevTools and play around with it. Put different values in there. Hard code some values if you want. See what happens. Porik, Naz, Ewan, making a bit of sense?
Yeah, it's making a bit of sense, but it's something I need to go over.
Yeah, of course. Yeah. No. don't want you to learn parrot fashion anyway. I want you to understand it at each step and be able to reproduce it. Yeah. 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 All right. All right. The accents are coming out again. Yeah. Again, we could do this one using reduce. And if you notice, question 3 and 4 are very, very similar. They are essentially the same question, but you get some boilerplate code in question 4, and you don't have any boilerplate in question 3. So this is based on a previous student's attempt at the question, but unfortunately it was incorrect in a few ways. So you just have to debug it and fix it. It's not necessarily the optimum solution. We can look at a more optimum solution in a second if we go back to number 3. But can we spot any errors in there, or why it's not doing what the original author intended?
Well, we're trying to loop through the object.
Using a for-in loop, yeah?
And what we will be doing is returning on the very first run of the for loop, regardless of whatever happens. So we never see the second item in the object.
Absolutely. Yep, so we're always going to return something, and we're either going to return true or false, right, based on the first item, or we're going to return the result of recursively calling our function. Yeah, but we're not going to amalgamate those into one big loop or one big reduce function, for example. So how could we fix it? We might need another variable in there. I'm going to get rid of this break as well. I don't think we need a break, right, at any point.
I would put, so the way I solved it was, instead of saying return objects, say, seeing the first if statement, we say return object prop equal for number. So I would put that in the what's the word? I'll put that in the if statement. So I'd say I'd say return true if type of object is not a number and type of property is a number. But I suppose that's what redundant. I'd say return true actually.
So if type of the object's value is not equal to object, in other words, if it's a number or something else, I guess, right? But in our example, that is testing whether it's a number, yeah?
Yeah.
So we could just do that then, if you want to rewrite it to be positive. So if type of the value as we iterate over is a number, then do what? Oh yeah, so they are different checks, right? Because we're checking it against the original number. We're not checking the type is a number, we're checking whether it equals this number that we're looking for, number 4 in the first case. Yeah, so they are different checks. Yeah, I mean, of course you could do that instead, right? If you wanted to say remain positive.
So put number 6, so change line 5 into an else if statement. And then put the this number call back into that if statement.
You want to do what, sorry?
So put line 6 into line 5's if statement. without the return part. So exists number in object, problematic number, yeah. It's just a whole number. It's big.
Without the semicolon, yeah, I'll get rid of it. So.
And then we'll return, if that, then we'll return true. So on line 6 we can return true. And then at the very end of the for loop, so after the for loop, we can return false. So if at any point in the for loop, if at any point in the for loop we find that the object, the thing, is equal to the number that we're looking for, we return true. Otherwise, if the thing is not a number, so we'll have to check if it exists in the objects, the object. So we'll run that function again. And if that returns true, then we can just return true. And if after the for loop we haven't found anything, we can return false. And that would probably work.
Not convinced, but
Actually, yeah, let's put the line 4 into the if statement.
put what? Sorry.
Put line 4 into the if statement.
You want line 4 in an if statement as well, because that has the opportunity to return false, right?
Yeah, so we'll put and then that, then we'll return true.
Yeah, I'm not going to refactor it now. But yep. Yeah, so you covered all of your possible true conditions inside of if statements, right?
Yeah, that would be only return true if these things actually correct. Otherwise, we would be returning false and not really comparing anything else afterwards.
Wait, can you move to the right, please?
What, Vince?
Can you scroll to the right, please?
To the right, yeah.
Object. Oh, right, I can't remember. Yeah, makes sense.
It's one solution. I can give you a horrible solution that you'll never use, but you'll probably remember it. You'll use it to get points. Ricardo probably tell me off right for doing this, but we could object insert do I have to string it? I wouldn't have thought so.